Hello reviewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about USB-C everywhere. So let's dive right into it. Now we have to understand what's the idea behind USB-C. Well, one of the primary aspect is that it's symmetrically connector. So what does that mean? That simply means you can put it like this or like this. It does not matter. So that's the whole thing. So we no longer need to have that, USB ports are like freaking in quantum superposition. So that's the one desirable aspect, and it's much more smaller, far more reliable. Both side connector and the basically port, both are far more reliable. And the reason why you can have USB-C on both end, this is a very critical aspect. In early days of USB-C, there was a idea of basically master and student, basically a host device and a connected device. So host, if you reverse polar it, you will literally mess up the device. You will literally have short circuit issue. So fundamentally, engineers come up with this idea that master device will always have one type of port, and receiver device will have another type of port. For example, USB-A port, the thing that you see, the big ass USB-C port, USB ports, that will be directly on your PC. So you know for a fact that this big cable only goes there. And what will happen on your printer or your other devices, a connected device, they will have a different port. For example, USB-B. So you can never invert this reaction. So you will never have a short circuit issue. So that was a desired thing. However, nowadays computers are advanced enough that this can be managed. So you're gonna have USB-C on both ends. So we'll no longer in the future will need where you have giant USB-A cable with USB-C. So we'll not have USB to USB-C cables. All cable would be USB-C on both end, and they will no longer have that one must go to host, one must go to the student. That will no longer be the case. The cable would be truly symmetrical. And every Tom, Dick and Harry except Apple is working on making sure this becomes a universal standard, and I mean truly universal standard. To give you a context of that, right now in India you can buy basically power banks that have USB-C ports. You can buy chargers like my first F62 charger also has USB-C. Everything, including headphones, including basically I have a Bluetooth transmitter device, this also has USB-C. Everything is coming to USB-C. So reality is every Tom, Dick and Harry is working very hard on it, and over time it will become the port. Like, what do you have? You don't talk about it. You just have USB-C. You assume it, and unless you're dealing with Apple, you will be correct. Heck, even in Apple, unless you're talking about iPhones, you will have USB-C. Even their tablets have USB-C, even their laptops have USB-C. So USB-C is coming very close to becoming absolute universal. Now there are three parts to this. Now this is what makes USB-C so convoluted and so complicated. First, they have physical layer. What does that mean? That's simply what you can see. That's the thing that you see. Like, is it USB-C or not? Is it USB-C to display port? Is it USB-C to basically large USB-A? So that's the whole thing. That's the physical layer. You can directly see it. And there is another aspect of it which I will talk in the data part of it. But that comes to physical layer aspect of it. That's one layer. You may be like, okay, I can look at it and figure things out. Yeah, that itself is not good enough, because then it also has protocol layer. What does that mean? That simply means which language is speaking, so to say. So if it has the incorrect protocol, you will like, hey, this is supposed to use USB-C cable, is supposed to be compatible with Thunderbolt, but the moment you connect, it's like, lol, no, protocol incompatibility happened. And then you have power layer. Now because in the early days of USB did a very big push, micro B. Now the idea with micro B was that entirety of mobile industry except Apple will agree to this, and everybody will use one equipment. Now they succeeded. Now be mindful, this was done very early in the mobile's history, and consequences, the power requirement was not very high, so the inbuilt power requirement is very low. However, as mobiles became more powerful, as laptops became more power efficient, people came up with the ideas like, what if we have a much larger power envelope? So meaning going from the old days of 5 to 10 watts, what if we have 50 watts or 60 or even 100 watts? So power layer was created. Now this layer is independent of all the other layers, physical layer and protocol layer, and this will allow you to transmit data. So you could literally have the best cable that truly meets all the two criteria, protocol layer and physical layer. But if it's not built for that power layer, it will simply not work. So you could have a charger that is like GG awesome, like it's supposed to charge your mobile phone at 60 watts of energy load. You have a mobile phone that can absorb 60 watt of power, but if the power layer is not working properly, you will connect it and it will only charge at 5 watts, which might not even be a charging in nowadays. It will be just like it's strictly trickle charging it. So there are three parts of it. All three has to match up to for you to receive basically a perfect rating, where you're like, no, this is what my cable is supposed to do, this is what my cable is doing. So let's understand the power layer of it. Now you have to understand, if you start to pump 100 watt of electrical energy into a goddamn tiny mobile phone, it's gonna go boom. So fundamentally, to create safety, handshake was created. Now handshake has a fail safe. Basically, if the handshake fails for whatever reason, bad cable generally, or cable disconnection or something like that, like partial insertion, partial disconnection, it will go to fail safe and it will go to fallback. What does that mean? Fail safe means it will assume the worst. It will not maybe it's working, maybe it's working, I will send power. No. Fail safe. The end. Minor failure, done. Go home, sweet dreams, don't even think about it. Fallback. So power rating will drop down to 5 watt or sometimes even lower than that. And I can guarantee you at least 5 or 6 of you have this issue where you have connected your power bank, specifically power bank, to your mobile phone. You connected it, everything is fine and ready. It was charging, like it was showing, let's say 2 hours remaining to full charge, and then it randomly starts showing 11 hours to full charge or 20 hours to full charge. That happens generally. It has went to fallback layer, meaning the communication standard broke down, the handshake failed, and it's just like, nope, we cannot take any risk, go to the lowest power setting. And for higher power, basically, for example, laptops, you need basically charger and receiver both needs to do what we call negotiation. They have to talk, basically, so they can negotiate voltage and current. Be mindful, USB power delivery was built in such a flexible way that you can have one company that's like, we have only 5 volts but we have 5 amps. Some other company would be like, we have 20 volts but only 1 amp. So these two needs to be negotiated. That's why there must be a communication standard. That's why handshake is so important. You could literally have a scenario where one mobile phone is like, hey, I need 18 volt. Another mobile phone could be like, hey, I need 25 volts, and if your malfunction happened, you will fry your equipment. That's why failsafe was created. And because of this complex negotiation that it has to physically talk, sometimes you need a freaking IC for that. What does that mean? That simply means your USB-C cable becomes active cable. It's no longer just connector. There is like a freaking IC that literally talks to the charger and to your device, and if that fails, you will literally go to failsafe. And this, I can tell you, that is one of the things that makes USB-C, proper USB-C cable, so expensive. Even in some scenarios, people wanted to utilize a registered network to create a handshake signature. That also malfunctioned. So OnePlus had a very serious case of that. So reality is, right now a proper USB-C cable is a generally active cable, meaning it has an IC on board, and that IC is responsible for handshake. Now if you have a proper USB-C with proper IC with proper handshake, then you're gonna have amazing specs. Then you can be like, hey, I'm connecting my power wall adapter to my laptop and it's charging at 100 watts. That means you generally have a very good IC. Generally normal cable will not go up to that level, and depending on the charger, depending on the protocols required, you could have a passive cable that is just cable and it can go up to 50 watts. That matters different to different. And this is another aspect of messiness. It's like nobody says like all cables have to be IC driven. It's like some cables are IC driven, some are not driven. So what we call these ICs are like E markers. So they do the handshake, and I can guarantee you the moment you are dealing with an issue where it's like, dude, my charger is GG, my mobile phone is GG, but why the heck charging is not working? Generally it's a cable fault. So in some cases you need that active IC cable. And if you're like, how the heck Apple makes sure that you can't utilize other USB-C equipments or other chargers on Apple devices? That's how they make sure the manufacturer who's making the e-chip, they have a exclusivity agreement. Basically that IC will not be sold to any other third party. So the Apple is like, no, lol, fu kind of thing. So fundamentally speaking, this is another issue with USB, where you have to figure out, is my cable passive or is my cable active? If my cable is active, there is no standard for it. It's like IC standard A7, there is no standards for it. Like for developers there is, but for common person, no. Then we come to the data layer, and this time makes it even more convoluted, because most of the cable that you see on Amazon or things like that, they are generally USB 2.0. What does that mean? That simply means it physically has few ports. It physically only has 4 ports and 2 data lines. So fundamentally it cannot transmit data at very high speed. So you can have a laptop which is like ludicrously powerful. USB 3 ports, it can travel at 500 Mbps. Your mobile phones, USB 3, USB-C port, you're like 500 Mbps. So I should be able to transmit like large video files from point A to point B. You're connecting, it's like, wait, why it's only transmitting at like, both parties have SSDs, then why the heck I'm only transmitting at like 40 Mbps? The reality is the cable is USB 2.0. So you have to buy a cable that is USB 3.0. So basically that utilizes all the pins, not only for all the pins. And if you're like, that would make it expensive, yes, it does make it expensive. On top of that, it also requires handshake. So you can understand the handshake is the weakest link in the system, and some works on passive cable, some requires active cable. Generally Thunderbolt cables have to be active, otherwise they will default back to much slower speed. So this is another issue that we have to deal with, is like, is it power delivery capable, is it data delivery capable, is it doing the handshake? That's why you will always find IC network chips for high cable that is truly rated and certified, where it can work with either with DisplayPort or Thunderbolt or USB-C high speed system. So to seeing the situation, like how messy the situation is, so USB 4 is being created now. This is supposed to be launched in 2020, late 2020, but because of the fact that world went boom, the implementation is much behind schedule. So at this point in time, expect 2022 when it becomes the mainstream. Now idea is that this will make basically a standard cable for everything, meaning it should even have the feasibility of actually replacing HDMI also. So a proper cable that can do everything. Now it's supposed to have USB-C as a core port. This is one thing that they are agreeing from day one. You will no longer have a port size, basically USB 8 that can claim USB 4. It does not matter. It's like you have to utilize this plug, otherwise don't talk about USB 4. So that's one thing, they are removing that element. So now again, at this point in time, it's only a legacy issue, but still it's making sure that if you are claiming USB 4, you must have this port. And you may be like, what if I want to connect a USB 3 device to it, and which uses full size ports? Yes, you can use that using a dongle. Then it will also have PCI Express tunneling through it. So basically Intel, who is the sole proprietor of Thunderbolt protocol, they have decided to open the Thunderbolt protocol 3. So they went to USB association and it's like, here's our protocol, take it and make it on your own. So USB 4 has Thunderbolt 3 as its core background layer. Now you may be like, why the heck Intel is selling this technology? Not selling, as in like almost giving it away. The reality is Thunderbolt is not picking up the same way people expected it to. It is a very big deal for Mac users and a big deal for some Intel users, but trust me or not, but like not enough people use those things. So device manufacturers are not very eager to pay Intel in order to utilize that. So Intel's strategy is here is like, we're gonna give you USB 3 and we're gonna make USB 3, pardon me, Thunderbolt 3, and we're gonna make Thunderbolt 4. Now Thunderbolt 3, it will allow wide scale adoption because it will be now available with USB 4 default. So every Tom, Dick and Harry can buy Thunderbolt 3 devices. That will increase the adoption, and then people will be like, Thunderbolt 3, I'm using Thunderbolt 3 in my USB 4. Thunderbolt 4 claims even more reliability, even more stability. What if I invest in that? So basically it's almost a seeding strategy, and this will also allow a lot of PC users to jump into Thunderbolt bandwagon. At this point in time, Thunderbolt is almost something that you only see big YouTubers stealing about. The reason is that it's like, it's too expensive, because they have to pay Intel royalty fees, and there is not enough demand for that. So to compensate that, Intel is like, okay, take the Thunderbolt 3. So USB 4, the core protocol layer is basically this Thunderbolt 3, and it has PCI Express transfer. So it will allow that, how you see external GPUs being connected, that's integrated into the system. Then you have DisplayPort 1.4a based tunneling into this puppy. Now that's awesome, because I specified this puppy has the capability of replacing HDMI cables. So you could literally have a scenario where your mobile phone just have a USB-C, plonk, USB-C, plonk, done. Don't even think about HDMI. Like, what is HDMI? It's like, why the heck you want to pay HDMI association for something? And you may be like, DisplayPort does not have it. It has everything. It also has that security encryption and all that jazz. It has even better version of that, and it's also open source. You don't have to pay anyone. So USB-C could become something that slowly over time could replace finally this weird thing of known as HDMI. And then be mindful, HDMI versus DisplayPort. DisplayPort is generally 2 generations ahead, and it's free. So DisplayPort tunneling, that could also become a big thing. Then it has USB 3.2. So in case if you're not compatible with the Thunderbird protocol, you still can utilize USB 3.2, meaning 10 Gbps bare minimum speed transfer, which is like almost around 1 Gbps, capital B, transfer speed. That is very good speed. And if taken to its maximum limit, basically if everything is working, basically your transmission device and your reception device, all of them are working, the cable is correct, cable is active, everything is working, it has cords, everything is working, then it should give you up to 40 Gbps, which is like same speed as Thunderbolt 3. Now that's the aim of this. So idea is that they will have a proper rating, proper certification, and if the cable claims that it's USB 3.0, it basically USB 4, it should work. It should just work. You don't have to think about, hey, will it support a DisplayPort? No, you don't. Will it support Thunderbolt? You don't have to think about it. If it's proper, not a counterfeit, you should not need to think about it. That's the end goal here. So everybody is working on this end except Apple. don't think about Apple. Let go Apple, because Apple is like, let's make more e-waste. So remove that. Other than that, every Tom, Dick and Harry is on board with this puppy, and everybody wants them to succeed. So this was my presentation on USB-C everywhere. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.